So we continue by looking at some more examples of solving equations. And again, we're just going to slowly build up to ones that are a little bit more complicated. So in this next example, we happen to have variables on both sides. So our goal, again, is to get the variable to be on one side by itself. So when it starts out on two sides, then we need to either make the 9x go away or the 5x go away. It's completely up to us. I have chosen here to make the 5x go away. Since it's a positive 5x on the right hand side, I have to subtract it. And I also subtract it from the other side. That now gives us an equation where we have 4x minus 8 equals 7. So now the variable is just on one side of the equation. Just on one side of the equation. And so now we can focus on getting the variable by itself. So we need to make that minus 8 go away. So as we saw in the last video, it's easier to do addition property first. So we go ahead and add the 8, move it over so that it's on the other side. And now we're left with just 4x equals 15. At this point, we can finally use our division step to get rid of the 4 that's in front of the x. We can do so by dividing, and we get the answer x equals 15 over 4. And now the next example is going to take a real big leap forward here as far as difficulty. As you're working through these problems with me, you may want to pause at times and try to work out some steps yourself. Or just to kind of catch up. If I'm moving a little quickly through the video, you can always pause it. So here we have a bunch of stuff on both sides of my equations. 9x plus 12 minus 3x plus 7 equals 2x minus 3 plus 8x. Whew, it's a whole mess. What we want to do first is simplify. Like we did in an example earlier, we want to simplify. So that means we want to go through and match up our like terms and put them together. Now you can rearrange it like I did in a previous video, but what I like to do is just kind of mark them off. Or use a highlighter. So 9x and 3x, they're like terms. 12 and 7, they're on the same side, they're like terms. And then on the other side here, I have a 2x and an 8x. Don't have anything for the minus 3 to go with, so it'll just kind of tag along. And then we go through and combine those like terms. So 9 minus 3x, 9 minus 3 would be 6x. 12 plus 7 will be 19. And then on the other side, we have a 2x plus 8x will be 10x minus 3. Okay, at this point, our equation is much like the one we've just had. It's much like the equation that we just had. Now we can focus on getting the variable onto one side. So that means we either need to get rid of the 6x or get rid of the 10x. So I elected here to get rid of the 6x by subtracting that from both sides. You could have also subtracted 10x from both sides. That would have accomplished the goal of getting the variable on one side. It'd just be on the other side. So as we simplify here, the 6x's go away. We get 19. 10 minus 6x is 4x. And then minus 3 just tags along. At this point, the variable is just on the one side. So now we need to get it by itself. So we take the 3 and we add that to both sides. On the left right hand side, the 3 minus the minus 3 go away. 19 plus 3 is 22. So now we're down to 22 equals 4x. 22 equals 4x. So at that point, we're ready for our division step. So we divide by 4. This time, the fraction can be simplified a little bit because we have 22 over 4. So we can take a 2 out of both, 22 and 4. And we get our answer 11 over 2. 11 over 2. So x is equal to 11 halves. Now before we conclude this problem, we got a warning here for you. Watch out. watch out. Because there is a really common mistake that a lot of students will slip into in a problem like this. The common error is this. So if I rewrite my equation, just as it was before, 9x plus 12 minus 3x plus 7, 2x minus 3 plus 8x, people really get into the habit and thought of moving stuff, which is not in itself a bad thing, but what I'll see people do is this. They'll add that, they'll see the minus 3x there, so they'll say, oh, I've got to add it. And then they'll come underneath the 9x and they'll add that. And then we get a result that's like this. Unfortunately, that's not a correct result. The problem here is this 3x that we've added was added onto the same side. And when we add stuff, it has to be done on both sides of the equation. And so what we've now done by adding that 3x like we did there is we've overbalanced the equation. The other side of my equation here didn't get that 3x added twice. So it's actually off by a 6x. And so this is a really common mistake. It's so easy to fall into. And so for that reason, I really encourage you to kind of get this idea ingrained. Simplify first. Then you'll have just one variable on each side and a number term on each side at the most. And then you can proceed to solve the equation.